Okie doke. We have lesson 6.2.3 and this is day 2. Yesterday was day 1 and this is for 7th grade. I am starting with a warm-up problem and it's a problem we didn't do yesterday, but we're going to do it right now to warm up because this is basically the type of problem we're dealing with today and we want to be familiar with it right off the bat. So we're given this equation and it says to solve for x and then check your solution. It says you may want to build it on your equation mat, which is an option if you'd like to do that, but I'm going to do it algebraically. And the first thing I ever want to do with these types of equations is to start combining your like terms on each side of the equation first before you start transferring stuff from one side to the other side. You want to combine all your like terms first. See, now this side you can't combine any like terms, so this side's done. You can't do anything to this side at the moment, but this side I do see something that we can combine together, and I see we have two x terms here that we can combine, and if we have a positive 5x and we're adding it to a negative x, we're going to treat that like subtraction, and 5x minus 1x is 4x. I'll write it in red. And we don't keep the negative because the 5 is the bigger number here and the 5 has an invisible positive in front of it. So that means we keep the answer positive. Bring down the negative 1. 11 minus 2x stays the same. So now that we've combined all like terms on both sides, now we have the green light to start matching sets on each side. Basically what that means is we want to get x on one side and the ones on the other side. And usually you'll see the x on the left side, but that's okay if you want the x to be on the right side. It really doesn't matter as long as that x is positive at the very end. So let's see what we can do next. And I guess I'll do it in black. I'll just switch colors every step. So I noticed that I can move a 2x out of here. So if I have a negative 2x, I want to add a 2x because I want x all by itself over here. So let's add a 2x to make that 0. Have to do the same to the other side to maintain the equality. 4x plus 2x gives us 6x, minus 1 stays the same, equals 11, and that becomes 0. So now we have 6x minus 1 equals 11. We can get x all by itself with one step. And what I want to do is match this negative 1 to that side by doing this, adding a 1. Because this gets rid of that situation. That becomes 0. Have to do the same to the other side to maintain equality. 6x equals 12. And the last step to get x all alone is to undo this multiplication here by dividing by 6 on both sides. And I'm left with 6 divided by 6 just gives me a 1. And I don't even have to write the 1. Bring down the x. 12 divided by 6 is 2. So it looks like our solution here is x equals 2. It does say to check your solution. So in order to check the solution, we need to plug 2 into every x in our original equation. So I'm going to erase the steps we just did to make room for us checking the solution. Okay. So if we think that x equals 2, let's plug that 2 in for every x here. So let's do 5, and that just means times 2 plus negative 2 minus 1 equals 11 minus 2 times 2. Now I just need to simplify all the way down until I get one number on one side and one number on the other. So 5 times 2 is 10 plus negative 2 minus 1 equals 11 minus 4. I'm just multiplying first. Now I can start adding, subtracting. So 10 plus negative 2 gives me 8 minus 1 equals 11 minus 4. 8 minus 1 is 7. 11 minus 4 is 7. We're good. So x equals 2 is the solution, and we checked it. So that's our warm-up for the lesson today. And we're going to start with problem 678. 6-78. Let me get my notes ready. Okay. 678 reads, Maggie's mom agrees to let Maggie buy small gifts for some of her friends. Each gift costs $4. Maggie's mom gave her a budget of $19. When Maggie went online to order the gifts, she discovered there was a $7 shipping fee no matter how many gifts that she bought. So this is kind of reminding me of the bowling situation that we had yesterday with the shoes. I think it was yesterday, the shoes and the games. And there was always a flat rate for shoes. So now we've got the same thing. We've got a flat rate for shipping, which is $7. So that means that no matter how many gifts you buy, you're always gonna tack on $7 at the end. So let's look at A. It says use arithmetic, so without any variables, to determine how many gifts Maggie can buy. So I'm gonna write down what we know. Each gift is $4. Her total budget is $19. Whenever I know a total, I know that that's probably what we're going to set the equation equal to. And shipping fee equals $7. So that's going to be like added on to the end. So let's do this without arithmetic. So here's what I did, is I thought, I literally did a guess and check. So I had my number, or not my number, this is the price of gifts, 4, and then I guessed, I guessed 3, and I actually was right. I don't know how I did that. It was some sort of magic. So 4 times 3, I was guessing, and then plus 7. So I thought, well, if she bought 3 gifts, multiplied that by 4, she'd get 12, add the $7 shipping fee, 19, 12 plus 7 is 19. So luckily, my guess and check method was quite efficient here, but it's not always as reliable as it just was, because some people might have said 2, some people might have said 4, some people might have said 10, and then it would have taken them a long time to get down to the number 3. And it kind of reminds me of our 5D process, where we have a lot of like trials you have to do and think, okay, at the end, is it too big? Is it too small? Now you have to adjust your guess or your next trial number. So that's part A. I used a guess and check method because 3 was my guess and it miraculously worked. So part B is asking, write an algebraic equation to determine how many gifts Maggie can buy with $19 and solve your equation and record your steps. So in the previous problem, what I just erased is actually the start of our algebraic equation. So we have 4 is what we started with because that's the rate for gifts. And then we don't know the amount of gifts. Okay, say we didn't do problem A, we have no idea the amount of gifts. And if we don't know a number in a math problem, we use a variable. And I'm just gonna use X because we've been using X. So 4 times X plus the shipping fee, because that's going to be the same no matter how many gifts she buys. And I set it equal to her total budget, which is 19. So that is our algebraic equation. Now if we were to solve it, which it's telling us to do for B, we're going to first find my red marker. There it is. And then we're going to transfer the 1s over to this side because this 4x is almost by itself. It's almost alone or isolated on one side of the equal sign. So let's move this 7 to this side. And the way you do that, to get rid of a plus 7, you minus 7. So plus 7 minus 7 cancels to 0. Bring down the 4x. equals 19 minus 7, which is 12. Almost done. X needs to be all by itself, and I want to divide by 4 to get x by itself. Have to do it to both sides, or it's illegal. So 4 divided by 4 is 1. I'm left with 1x equals 12 divided by 4, which is 3. And that is the solution that we came up with in part A. And now it says for part C to compare and contrast the two methods. So part A was the arithmetic method, part B was the algebraic method. So it says to compare and contrast. So we kind of want to see the pros and cons of each method. So what I was thinking was arithmetically, or the guess and check method, it was not as reliable. So arithmetically, it was guess and check. Not as efficient as algebraically. So then, on the flip side, algebraically, I want to think what was good about it. Well, it felt a lot more precise, and you get the answer the first time, as opposed to possibly guessing and checking a million times to get the right answer. So algebraically, it was more precise. And you get the answer or solution the first time through. There's no guessing and checking. There's just a set equation that you can solve for the answer the first time. And that is 6-78. And we're moving on to 679, which is actually one of the last problems. We are going to do the learning log for this one because we've kind of been neglecting those. But 679 is going to give us a series of equations to practice with to solve for x. And they can get quite complicated, so let's go through them. So 679 is, part A is this equation. Whoops. Okay. So what I'm looking at first is parentheses. And when I see parentheses and I see two things inside the parentheses, I know I need to do some distributive property. So let's distribute this 2 to everything inside the parentheses adjacent to it. So 2 times x is 2x. 2 times 1 is 2. So we're done distributing with that one. Bring down the 3. Oh, we got another distribution. Distribute that 3 to everything inside. So 3 times x gives you 3x. 3 times -1 gives you -3. So now that I've distributed properly, now I can start combining like terms, because I noticed that I have some like terms to combine before I start transferring numbers to the other side. So I see this 2 plus 3, which is pretty easy, is 5. Bring down everything else. Now I'm at the point where I can start transferring things from one side to the other. And I'm actually gonna do something different than what I actually did in my notes, because I want to show you what happens if you have a negative x on one side of the equation. So I'm going to do it differently how I first did it, because some people might do it this way. So usually you see x on the left side. So if I want to get x all alone over here, I need to get rid of him here. So if I want to get rid of a positive 3x, I minus it from itself to make 0. So that becomes 0. 2x minus 3x gives you a -1x. don't even have to write the 1 in front, plus 5 equals -3. I'm going to check to see if it's recording. Is it recording? Yay, it's recording. Okay. So now I almost have x alone. I just need to get rid of this 5. So to get rid of a positive 5, you would minus 5. I'm not doing it in black. You want to minus 5 from both sides. So that becomes 0. Bring down the negative x equals -3 minus 5 gives us a -8. So I don't ever want a negative x. I can't leave this the way it is. I need x to be positive. So to do this, here's the trick. You divide both sides by a -1. If you divide both sides by -1, negative divided by a negative gives you a positive. So this just becomes positive x, and that just becomes positive 8. So it looks like our answer is x equals 8. Let's check that with our checking method, our plugging back in method. So let's see, 2 times 8 plus 1 plus 3 equals 3 times 8 minus 1. And I'm just plugging in that x, plugging that 8 for all the x's. 8 plus 1, so 2 times 7, whoa, 8 plus 1 is not 7, 8 plus 1 is 9. Plus 3 equals 3 times 7. 2 times 9 is 18, plus 3 equals 21. 18 plus 3 is 21. 21 equals 21. So x equals 8 is good to go for part A. Part B gives you this equation. Oops. -2x minus 2 equals 3 times -x plus 2. Okay, so I see parentheses first, so that means I need to distribute. So I need to distribute this 3 to everything inside the parentheses, which just means to multiply it to everything inside the parentheses. So now I'm gonna write in red. This stays the same, I didn't do anything here yet. 3 times -x gives you a -3x. 3 times 2 gives us positive 6. So now I'm ready to start transferring things to the other side. So I'm going to transfer this 3x. If you want to get rid of a -3x, you want to add a 3x to both sides. So -3 plus 3 is 0, so that's 0. -2x plus 3 is just 3 minus 2, which gives you 1. So you're left with just x minus 2 equals 6. And you might already know the answer by now, just with knowing subtraction. But I'm going to show you the steps anyways. To get x alone, I want to get rid of this -2. To get rid of a -2, you add 2. Make sure you do it to both sides. That becomes 0. And x equals 8. Same as the last problem. Now it wants us to check it. So we are going to, I'm going to write down the answer, x equals 8 up here so we don't forget. Erase the work that we just did. And then, and I'm only erasing because I don't have room. You're not going to erase all your work. You're going to keep it there. You're just going to write all of this underneath. Okay, so let's plug in this 8 for all the x's. -2 times 8 minus 2 equals 3 times -8 plus 2. -2 times 8 is -16. Minus 2 equals 3 times -6. -16 minus 2 gives you -18. 3 times -6 is -18. So x equals 8 is the solution for part A and B. Parts A and B, x equals 8 is the solution. Okay, we have 2 more parts to this problem, and then we'll do the learning log and then be done. Okay, part C. We have 3 plus 4 times 2 minus x equals 3x plus a negative x minus 7. All right, I see some parentheses, and I see 2 terms inside these parentheses, so I gotta distribute before I do anything else. So let's do that. 4 times 2, 4 times negative x. So let's rewrite everything. 3 plus 4 times 2 is 8. 4 times negative x is negative 4x. Bring down the equal sign. 3x plus a negative x minus 7. Now I'm ready to start combining like terms on both sides. So if I see a 3 and an 8 that can be combined over here to be 11 minus 4x equals 3x plus a negative x, which is 2x, minus 7. Now I'm ready to transfer things to both sides. So if I want to get x, I want to get x on this side right now. I need to get rid of this 2x. So if it's a positive, you subtract 2x. Subtract 2x, that becomes 0. Bring down 11. Negative 4 minus 2x is a negative 6x equals negative 7. And now I need to get this 11 out of here, and it's a positive 11. So I'm going to subtract 11 to get rid of it. Same thing on the other side. 11 minus 11 is 0. Bring down negative 6x equals 7 minus 11 gives us negative 18. Yes. Now let's get x all by itself by dividing each side by negative 6. And x gives us positive 3. Because a negative divided by a negative is positive. So we came up with x equals 3. I'm going to put it up here so we remember while we're double checking the solution. Erase this work. And time to plug it in. 3 plus 4 times 2 minus 3 equals 3 times 3 plus a negative 3, yes, minus 7. Okay, we just start simplifying. So let's see, 3 plus 4 times negative 1 equals 9 plus negative 3 minus 7. 3 plus negative 4 equals, let's start simplifying over here. 9 plus negative 3 is just 6 minus 7. 3 plus negative 4 is negative 1. 6 minus 7 is also negative 1. So x equals 3 is confirmed as the solution for this problem. And the last algebra problem for the day is part D, and it's a longer one. I'm gonna roll up my sleeves. 6 times 3 minus x plus negative 20 equals 10 plus 3 times 4x minus, or plus 2, sorry. Okay, whew. I see some distributing to do. Let's do our distributing first. So let's distribute the 6 to everything inside its parentheses. 6 times 3 is 18. 6 times negative x is negative 6x. Pull down the 20. Negative 20 equals 10 plus, more parentheses, we need to distribute. 3 times 4x is 12x. 3 times 2 is 6. Now's our chance to combine like terms. So I'm looking at this side, and the 18 and the negative 20 can be combined. So if we do 18 plus negative 20, we end up with a negative 2. And I'm going to minus a 6x from that because we bring that guy down. Over here we can combine the 10 and the 6. So 12x plus 10 plus 6 is 16. And now we can start transferring. So if I want to bring the x's to the left, I want to get rid of this positive 12. So I minus a 12x from both sides. Get rid of that. That becomes 0. This becomes negative 2 minus 18x equals 16. And almost done. We want negative 18x by itself, so this negative 2, we need to add a 2 to make it 0. Have to do the same to the other side. And we're left with negative 18x equals 18. Last step, get 18, or to get x all by itself, we divide by negative 18. So x looks like it equals 18 divided by negative 18 will give us a negative 1. So let's double check that. Let's plug in negative 1 for every single x that we see. So let's start bringing it down. 3 minus a negative 1. So that's minus negative 1. So be careful there. Plus negative 20 equals 10 plus 3 times 4 times negative 1 plus 2. We have a lot of simplifying to do. So parentheses first, 6 times 3 minus negative 1. In my mind, I just visualize that as 3 plus 1 because you're doing the opposite of a negative. And it's kind of a double negative, it gives you a positive. So 6 times 4 plus negative 20 equals 10 plus 3 times negative 4 plus 2 is negative 2. So let's do our multiplying. So we have 24 plus negative 20 equals 10 plus a negative 6. You could also write that as 10 minus 6. 24 plus negative 20 is just like subtracting. 24 minus 20 is 4. 10 plus negative 6 is just like subtracting. Also 4. So x equals 1 is a confirmed solution. Okay, those are the required problems, but I do want to go over the learning log really quickly. The learning log, I'm going to set mine up by titling it Solving Equations and Checking Solutions. So it's asking, explain what it means to solve an equation. What is a solution? Be sure to give an example, title this entry, and include the date. And the date, for me at least, is 3/26/20. So it says, what is a solution? What does it mean to solve an equation? So I started my sentence as solving an equation means and it's basically what we've been doing in the past lessons and in the lesson we just did. The whole time we were solving for x, so we were finding the value of the variable that makes each side of the equation equal to itself. And that's exactly what I wrote. So it means finding the value of the variable. It just means solve for the variable. That makes each side of the equation equal. And that's what we did every time we checked it. We were making sure that both sides ended up equal. So I did a short example. And I kind of stole it from one of the things we just did, but I made it shorter. So if you have the equation 4x minus 1 equals 11, you can solve for x by getting rid of this -1 by adding a 1 to both sides. And I'm left with 4x equals 12 on the other side. To get x alone, I want to divide by 4. So now x is by itself on this side, and 12 divided by 4 gives me 3. If you wanted to check it, you just plug that x back into the original equation. So if we want to check, this is our check area. So let's plug the 3 back in for x. So 4 times 3 minus 1 equals 11. 4 times 3 is 12. Minus 1 equals 11. 11 equals 11. So x equals 3 is the solution. And that is what I put for the learning log for 6.2.3, and this is day 2. And that's it. And I believe 6.2.4 is tomorrow. Yep. And that's it. So 6.2.4 tomorrow. Bye-bye.